All right, so here we go. We are recording, right? The review for Unit 1, Algebra 2. I am September the 13th, 2023.
That's really small. Can't really see that.
Let me see if I can blow it up for you.
Wait, today's the what?
Is that better? All right. Today is September the 13th, 2023. And your test is tomorrow, September the 14th, 2023. Right? So, the review, number 1 says the sequence starts with 0 and 5. Give a rule the sequence could follow in the next 3 terms for that rule. If we let a of 1 equal 0, we could say that we add 5 each time and have an arithmetic sequence. Would you say that?
Yes.
So if we had an arithmetic sequence, how much would we add each time?
5.
So your common difference would equal 5, correct? So if we let a of 1 equal 0, then we could say that a of n is equal to your first term. Remember this? A of 1 plus, if we started with 1, we did the common difference times n minus 1, right?
Wait, Coach Allison,
Yes.
can you turn off that front row lights?
I can't turn off the front of the light. I mean, we can turn all the lights off if you want to.
Okay. Oh, you don't have to.
No, I don't have to.
Will you be able to see them?
Huh?
Will you be able to see?
I don't know.
Can we test that theory?
You can test that theory. We're just
Test the
recording.
theory. That line, that just lights the.
Glaring?
Yeah, it's okay though.
Try it. All right, I can see good enough if y'all can see that better.
Well, hey, turn your
Nobody
light
can
on.
sleep though.
Turn your light on. You have a light on your thing. Help. Here he is.
How about that? Can
you
y'all
see?
see now?
Can you see?
I can see.
Let's get it.
All right. That's the general rule, right? For an arithmetic sequence, right? So RA of 1 is 0, so we would say that A of n is equal to 0 plus the common difference times n minus 1. And it said to find the next 3 terms. So A of 2, A of 3, A of 4 would be the next 3 terms.
This answer will be
No, we're not. We're making a video. We're not answering. Right?
Oh, you're making a video right now?
Yes.
Hey.
So here, A of 2 would be 0 plus 5 times 2 minus 1. We already got the second term, don't we?
I am confused.
What's that?
None of this makes sense to me.
This is what we've been teaching the whole time.
I know, but it's.
We're finding the next 3 terms. They gave us the first 2, right? They gave us the first 2, right? So we had A of 1 is equal to 0. A of 2 is 5. What's A of 3? What's A of 4? And let's see here. What would A of 5 be? Right? Now it says give a different rule the sequence could follow and the next 3 terms for that rule. Now this one, well, the problem with a geometric sequence is if a geometric sequence you start and you have a 0 term in there, how do you get a geometric sequence? What do you do each time to a geometric sequence? So what happens when you multiply by 0?
You're gonna get 0.
Or when you multiply 0 by something?
You're gonna get 0.
So a geometric sequence can't have a 0 term in it because otherwise every term would be 0. Well, we could start this with A of 0 instead of A of 1, right? We could start with A of 0 and say that equals 0. And we could say that A of 1 equals 5. And now instead of that, you remember what I told you for the equation when we had starting with A of 0? You remember the difference? This is when we started with A of 1 right here. Do you remember how I told you the difference to write this? We had it on the board the last 2 days. A of n is equal to, it's still the first term, but the first term's not A of 1 now. What's A of 1 in this one? If we're starting with n equals 0. A of 0. It's going to be 0 for this one, yes. But A of 0 plus your common difference times just n when we start with n equals 0. So in this case, our a of n would equal a of 0 is 0 plus our common difference is 5, so it would be 5 times n. And in this case,
But that wouldn't be, yeah, that wouldn't be defined the previous method, that'd be defined the next method.
yes, we're not doing that. We could do a recursive definition. That would be a good idea. What would a recursive definition look like?
It would be like, okay, so a of n equals 0. Equal 1.
A of n, recursive definition, let's go back to that. A recursive definition
I know the last part.
would be a of n equals your previous term. How do we denote the previous term? A of n minus 1, right? Times your common difference. So in that case, if you want to use a recursive definition, we would have a of n, I'm going to move over here. A of n equals your a of n minus 1, and what's our common difference?
Oh, 5.
And so in that case, we know our a of 0, or a of 1, sorry. A of 1 is 0. A of 2 is 5. So a of 3 would still be now, it would be a of 2, which is 5, plus 5, right? Sorry, I don't know why I did times. We're on arithmetic, right? We got to talk about geometry. Plus 5. So what's our third term going to be? What's the third term? 10. What's the fourth term? Not 20, we're adding 5 each time, right? So it's 15 again. It's the same as what it was before. And what's our fifth term? Same thing with what was before, 20. Painless? All right. That video is 7 minutes long for that first problem, so we're going to stop it there, okay?